Yeah. Yeah. So hi everyone, I'm Akshit Kumar. So today we are going to discuss about the gRPC. So basically, gRPC is a high performance RPC framework that leveraging the HTTP2 for transport and protocol buffers for the efficient serialization. So in today's session, we will be cover what is gRPC protocol buffer, and in last we will uh, cover in the demo all things. Right. So let's start. So here we have knowledge etiquette. So join the session 5 minutes prior to session start time, right? So we can conclude on time. So make sure to submit a constructive feedback for all session, as it is very helpful for the presenter. Yeah. So keep your mobile devices in silent mode and feel free to move out of session in case of you need to attend an urgent call. And please avoid unwanted chit chat during the session. So let's start with the agenda. So today we will be covering what is gRPC and what is protocol buffers, what is the flow of the protocol buffer, why gRPC uses protocol buffer, not the JSON, right? And why gRPC uses HTTP2, not HTTP1. And then next we will cover type of gRPC APIs and comparison between gRPC versus REST APIs. And in last we will showcasing a demo, and then we will going for the Q&A. Okay, so yeah. So what is gRPC? So basically gRPC is a high performance open source framework that is developed by Google. It enables the communications between client and server application by using the remote procedure calls, that is called RPC. So RPC allows client to directly call methods, right, on a server as if it were a local object, providing a simple, efficient, and flexible way to connect the services. So you can see here we have the clients and the service. So to communicate between the client and service, we will be use RPC framework. Okay, and yeah, it can be in any language. We can write the client in like Node.js and server in Java, in .NET, right? So it will be very helpful to communicate between two services. Okay, so protocol buffers. So protocol buffers is a method that developed by Google for serializing the structured data, similar to XML or JSON, right? So it's a language neutral and platform neutral. So you can write in any language, or you can run it any platform. So it allows you to be used for developing programs that can communicate with each other regardless of the language, right? So they are written in protocol buffers, define a strict schema for that data structure, which allows for efficient serialization and deserialization. So we are writing a file named as .proto, right? So we write some methods like the service, weather service, you can see here, and we are defining the temperatures. Same, we have a message like it will be request and the response. So this is done, and we need to just compile our proto file, and it will be generating all the code for you, right? Like the model classes, like your services. Okay, so we will cover this later. So next, yeah. So next, flow of the protocol buffers. Yeah. So defining a protocol buffer schema. For that, we need a dot proto file. So we need to we need to return a file in proto that describes the structure of the data, including message types and fields. Right. So you can see here, this is the protocol buffer file, where we have defined a services, template request, and the template response. Right. So here we will use the Proto C plus gRPC plugin to compile this protocol buffer, and it will be generated gRPC stub classes for you. Right. So the proxy compiler reads the .proto file and generates data access classes in various programming languages like Python, Java, C++. Right. Next, so here you can see gRPC stub after the serialization. Uh, Here all the classes will be created automatically by gRPC. Right. So here we have other service. We have temperature request and the temperature response. Right. So similar. Uh, it is like used to serialize the data into a compact binary format for transmission. Right. And yeah, so that serialized data is transmitted over the network, and when we receiving, like on the receiving end, that data again deserialized back into the original data structure using the generated classes. So like we have client and server. So we are serializing data here and sending to the server, right? And again server sending back a response, right, to the client, and where we will deserialize that data and use that response. Right. So yeah, next, I gRPC uses protocol buffer instead of JSON. Okay, so there are a couple of reasons to use uh, protocol buffer instead of JSON. For protocol buffer in smaller in size as compared to JSON, and parsing JSON is usually CPU intensive as it is plain text. But parsing the protocol buffer is less CPU intensive as it is binary and thus closer to how machine represents the data. So protocol buffer use uh, is more efficient than JSON in terms of both size and the speed. So protocol buffer use the binary format, right? It is which reduce the amount of data sent over the networks, right? And yeah, so you can see here in this image. So the JSON data, you can see JSON data is goes like this, right? And here protocol buffer sends that to the system. Like in JSON data, we are first serializing that data, then deserializing data, and then sending to the client. So that's the difference. And yeah, so if we talk about the speed, so the parsing and serialization of protocol buffer are faster compared to JSON due to their binary format and well-defined schema. So schema, right? So if we talk about the schema, so protocol buffers enforce a strict schema which ensure data consistency and helps in detecting errors at compile time rather than at runtime. So next, why gRPC uses HTTP2 instead of HTTP1? Yeah. So there are a couple of reasons not using HTTP1, right? So first one is multiplexing. So HTTP2 is support multiplexing that allows multiple requests and responses to be sent over a single TCP connection. But here you can see in the HTTP1, it is handle only one request response pair per connection. So here you can see we have three classes: index.html, three files, jiquery.js, main.css. So at one time, if we use HTTP1, at a one time we can send only one request, right? So you can see here as well. After completing the first request, we will send the second one. Similar for here. So, but in HTTP2, we can we can send multiple requests and responses to on a single TCP connection, right? And second, we have binary for framing. So HTTP2 uses binary framing, which is more efficient for parsing and reduces the overhead compared to the text-based format for HTTP1. Right? So and third we have like a header comparisons. So HTTP2 uses hatchback comparisons uh, for header, reducing the size of headers and improving the performance, especially for the application with many small requests. Right? So, so next, this one we already covered. So let's take an example of HTTP2 and HTTP1. So you can see here HTTP2 is uh, loaded all the images, but HTTP1 no. So if we take, yeah, so you can take see the differences. So HTTP1 taking time to load the images. So that's why we are using HTTP2. Okay. So next we have types of gRPC API. Right? So there are four types of gRPC APIs. So first is unary RPC, right? So the simplest form of this, where the client sends a single request to the server and receives single responses using the unary. And second, we have server streaming RPC. So server responds with a stream of messages to client's request. And third, we have client streaming. So the client sends a stream of requests to the server and receives a single response. And fourth, we have the bidirectional streaming. So in bidirectional streaming, both the client and server send a stream of messages to each other, and the streams operate independently, and both sides can read and write in any order. So next we have gRPC versus REST. So gRPC uses the HTTP2 and REST uses the HTTP1. So gRPC is a modern high performance framework that uses HTTP2 for transport protocol buffers, and it provides the features such as authentication, load balancing, and more. gRPC is designed for efficient communication between services in a distributed system. But if we talk about the REST, it is an architecture style of designing network applications. So REST uses the standard HTTP method like get, post, put, delete, right? And typically the JSON for data interchange. So RESTful services are stateless and rely on the standard HTTP protocol, that actually making them easy to use and widely adopted. So let's take a couple of comparison. Like first, if we take look about the performance. So gRPC more performant due to HTTP2 and binding serialization and the efficient use of resources. But if we talk about the performance of REST API, it is slower in comparison due to HTTP1 limitations and text-based JSON serialization. Right. So second, we have data format. So if we talk about the data format of gRPC, it uses the protocol buffer, that is a binary format that is compact and the fast. But if we talk about the data format of REST, it is uses the JSON, which is human readable but less efficient. And third, if we talk about the schema, so gRPC enforces a strict schema with protocol buffers, ensuring compatibility and the data integrity. But REST schema is not enforced. Flexibility can lead to potential inconsistency. So these are the couple of comparison. So let's move to the next. Okay, so before jump to the demo, I want to cover one more like differences between gRPC and REST API. So key difference between gRPC HTTP2 and REST API HTTP2. Yes. So REST API also use the HTTP2, but there are key differences between both in gRPC HTTP2 and the REST API HTTP2. Right. So let's take first difference is the serialization format. So I already discussed. I already talk about this. So gRPC is protocol broker, that is compact binary format, right? And it usually dot protofiles to generate code for data handling. And second, we have communication model. So gRPC follows an RPC model where client call methods on the server as if they were local functions. gRPC natively supports different type of RPC like unary. We have unary, server streaming, client streaming, and bi-directional streaming. But REST follows REST have HTTP methods like get, post, to delete, on resources to identify by the URLs, right? So third and last difference, we have streaming. So gRPC fully supports streaming in all directions, like client to server, server to client, and bi-directional. Okay. So but REST, while HTTP2 allows for streaming, implementing streaming in RESTful APIs, but it requires custom handling and is not a seamless integrated into the framework. So that's why we are use gRPC HTTP2, not HTTP1, right? And in REST API we use HTTP1, not HTTP2. Okay, so let's move to the demo. Okay. So first we will look into the home.xml file where we added all our dependency for gRPC. Right. So first we have gRPC Spring Boot starter. It is a starter dependency to run our application. Second, we are using the protobuf prot.ca. Basically, it when we compile this home.xml, right, it will generate the other files, right? Like we have order.proto file. When we compile, so it will compile, basically it will compile the order.proto file and it will generate all the code related to this file. Let's take a look into the order.proto. So it starts with the syntax proto3, right? And we have like option Java, multiple files and packages, right? So here we have defined a service, student service, right? And we have one method like that student, that accepting the student request and returns the response. So we have request here like ID, and we are returning the response string in a name and age, right? Okay, so yeah, so here we have server, right? So let's see, it is already compiled, like order.proto file already compiled. So I'm showing you now how it generates the classes. So you can see here student.request. So it is automatically generated. We just write the three line of code in order to protofile, right? Like request, response, and services, right? And here it is generated. So we can see here we have student request class that extend protobuf.generate messages, right? And it implements the student request builder. So this class we will going to use to send the request, student request, right? So let's move to second. Yeah, student service IMPL base. This is the service that we have extended here. So here you can see we have a couple of methods, right? So here it is using the student request and response methods to get the student details. Like we have one more method like that student. So here we have override that method from the student service sample base get student, right? And here we are using the request and the response observer. So we have here using the student response class, and we have hard coded the like response here like age and the name. Okay. So next we will see the client code. So here we are using a scanner class to take the input at the runtime. We are using the manage channel to communicate the server, and it will be run on port 6565. So here we are using the student server gRPC basically. Yeah. All the codes is already there, right? So we have to just use. So we didn't need to write the controller. Sorry, we didn't need to write the controllers like we are adding in writing in the dash API. So we have to just write a service class and our request and the response, and it will automatically generate all the code for you. Okay. So here we are like using the student response class to getting the student details here, right? And basis on the student ID. So we will take the input at the runtime, right? And it will return us the response. So let's run all the classes. So first we have the server. Let's run this server. Okay, so next we have the client. Let's I will put this client as well. Okay, so yeah, so here you can see it is asking of the student ID. So let me pass the student ID here, and yeah, so you can see we got the response, name and the age. Right? So yeah, that's all from my side. So now it's time to take the questions. Yeah, let me know if anyone have any questions. there is no questions, right? So, Pratiksha. I am audible, guys?
Yes, Akshat, you're audible.
Yeah, so I think we are done.
You're done with your session?
Yeah.
Okay. Thank you so much for your session. Anybody else has any questions or queries that you would like to ask Akshat? And if Akshat has any answers to the same?
Please ask questions if you have any, and you can reach out to me.
Yeah, Akshat,
Right? Yeah.
can you tell me the bold points of alternative of gRPC?
Okay. So alternative of gRPC, right?
Yes, yes.
Okay. So alternative of gRPC. Let me check. Okay. So there is one like Rest we can use, right? Alternative if we talks about the alternative, but we have like GraphQL also we can use, right? So there are many alternatives we can use. So I will ping you in the chat, right, to get more
Yeah,
details
yeah,
about
sure.
that. Yeah,
Thank you.
yeah.
Anybody else with any questions, guys? Okay, so I suppose nobody's having any questions.
Yeah.
Okay. Thank you so much, Akshat, for a wonderful session and congratulations on your session. Thank you so much,
Thanks
guys,
for
for being a wonderful audience. Thank you, everyone.